In this lesson, we will be looking at forming confidence intervals for population proportions. A lot of the things that we do in this lesson will feel very familiar because it's very closely related to the previous two lessons. The main difference is that this time we will not be forming confidence intervals for population means. We will not be doing confidence intervals for averages. We will be doing confidence intervals for proportions. So we will need to find a point estimate for the population proportion. We will then construct the confidence interval for the population proportion. And once we have constructed that interval, we will be interpreting it. And very similar to how we did in the previous lesson, we will also be determining what's the smallest sample that we can use if we want to estimate a population proportion up to a certain level of confidence. So as I mentioned earlier, in the previous two lessons, we constructed confidence intervals for population means. We were constructing confidence intervals for mu. And when we did that, we used the sample mean as our point estimate. The sample mean was denoted as x bar. However, in this lesson, we will be constructing confidence intervals for the population proportion. And the symbol for the population proportion is a p. The point estimate that we will use is the sample proportion. And that sample proportion is denoted with the symbol P with a hat on top of it. And it is very important that we do keep up with the different notation, the same way that it's important to know the difference between x bar and the difference in mu. When we were using the formula in the last two lessons, we also have to know the difference between P and P hat. To form the sample proportion, the formula that we use is P hat is equal to x divided by n. And x represents the number of successes in the sample, and n, just as it always has been, is the sample size. So for example, think back to that project that you did with the percentage of Americans that smoke cigarettes. You found that that percentage was about 12.5 when you Googled it. So in that case, that's kind of equivalent to saying that you had a sample size of 100 and that 12.5 out of those 100 people smoke cigarettes. So X would have been the 12.5 and N would have been the 100. Obviously, it's not possible for 12.5 people to smoke cigarettes, but we've seen that when we're taking these proportions, or even sometimes when we're taking these averages, working with continuous variables, we get statistics that don't actually have a meaning, but they give us a very good indication of where we're at in that sample. So we've talked about how P hat, the sample proportion, that gives us an estimate for the percentage of successes in the sample, or the percentage of people that smoke cigarettes, for example. The point estimate for the population proportion of failures, so the percentage of people that do not smoke cigarettes, is denoted as Q hat. So just thinking about that same example with people smoking cigarettes, if I'm saying that 12.5% of Americans smoke cigarettes, then I'm saying that, let me write this out. If I'm saying that 12.5% smoke, then it must be that 87.5% do not smoke, because we do know that these proportions need to add up to 1. So if we know what P hat is, we find Q hat by doing 1 minus P hat, because P hat plus Q hat must add up to 1.